Hi students, now we are going to discuss another very interesting thermodynamic process that is called by the name adiabatic process. The word adiabatic is a Latin word, just like the Latin word inertia we have studied in the previous chapters. So what is this word adiabatic means? Actually nothing passes through. Here we should mean it as no heat passes through the system to the surrounding or from the surrounding into the system. Okay, now let us define what an adiabatic process is. So it is a thermodynamic process in which the pressure P, volume V and temperature T of the system will change. All the three coordinates, the pressure, volume and temperature of the system is going to change. How? Under perfect thermal isolation. Isolation means what? Thermal insulation. So it means that there is no flow of heat from the system to the surrounding and from the surrounding to the system back. That is vice versa. Is it not? So for that I have considered an ideal gas taken inside a container, a cylindrical vessel whose walls are perfect insulator, bottom is also insulator and the piston and handle are also insulators. Okay, very simple. Now what will happen if I will compress the gas by pushing the piston in the downward direction? When I push the piston in the downward direction, will the volume decrease or not? Yes, volume will decrease. What about the pressure? Pressure should increase. Because of this friction with the different air molecules or gas molecules, heat will be produced. And this heat cannot flow out of the system because of the thermal insulation. So what happens to the temperature during a compression? The temperature should increase. Understand? The reverse of this, suddenly you pull the piston in the outward direction. So what happens to the volume of the gas? It increases. As a consequence, the pressure and the temperature will decrease. So my dear students, it is a very fast process, rapid or sudden process. So this process is very fast, and the example, different examples for this we can give. The bursting of a cycle tube or a car tube, the bursting of a cycle tube. Okay, then another example I can take, a propagation of a sound, through gases, propagation of sound through gases or through the air. Then expansion of gases inside engines, expansion of steam in a steam engine. So like that, steam engine is an external combustion engine, understand? Whereas petrol and diesel engines, no, gases, the working substance, namely the gases will expand and get compressed within the engine. They are called as internal combustion engine. So here expansion of steam in a steam engine. Similarly, expansion of gases in the petrol and diesel engines also we can write. These are all the adiabatic processes. Okay students, now the pressure, volume and temperature of a gas, these are called generally as thermodynamic variables. They are called as state variables. Now the relationship between the state variables is called equation of state, and here what are the different equations of state? For isothermal process we wrote PV is equal to constant, is it not? Like that here we are going to express three equations. So equations of the state variables, that is called equations of state, and the first equation is P multiplied by B raised to the power gamma is equal to constant. So it is a relation connecting the pressure and volume of the gas. Second equation, is temperature T into volume V power gamma minus 1 is equal to a constant. Okay. So this relates what? The temperature and the volume of the gas. And the third equation of state relates the temperature and pressure. So T raised to the power gamma into pressure P raised to the power 1 minus gamma is also equal to a constant. So these three equations are relating the thermodynamic variables which are called the equations of state. So these are three equations, if you remember, means it will be helpful in solving the numerical problems. Now the next one is specific heat capacity of the gas. So what is the expression for the specific heat capacity? So specific heat capacity is small s for 1 kilogram and capital C for 1 mole. So this is equal to delta Q divided by mass m into the rise in temperature delta T. Look at this equation. What is delta Q? Delta Q is a quantity of heat supplied to the system or rejected by the system into the surrounding. In an adiabatic process, no heat can flow into the system or come out of the system. Therefore, what should be the value of delta Q here? Delta Q must be equal to 0. So here, the quantity of heat delta Q supplied to the system is equal to 0. So in the numerator, if you substitute 0 means therefore the specific heat capacity of a gas undergoing adiabatic process is equal to 0. This is very important information. Okay, now the indicator diagram. So the PV diagram for this adiabatic process. Okay, indicator diagram we will now draw. So for this so the pressure P is taken along the y-axis and the volume V is taken along the x-axis. Now, what will be the nature of this PV diagram for three different gases I am going to draw now. For three different gases, monatomic gas. Monatomic means the molecule will be made up of only one atom. Understand? Like helium, let us take helium, neon. Then diatomic gases like the hydrogen, nitrogen, oxygen. Then polyatomic gases like the three different gases. If I draw the adiabatic curve means for one gas, let us say that it is very steep. So this curve is a rectangular hyperbola only, but the steepness of the curve will be greater than that of the isothermal process, because isothermal process is a very slow process, whereas adiabatic is a very sudden, rapid, very fast process. Therefore, the slope, okay, the steepness of the slope will be greater than that of the isothermal. So this curve is the PV diagram for one gas, some monatomic gas let us take. And similarly, let us take another graph for a diatomic gas. Okay, for a diatomic gas, it will be somewhat less steeper than the previous one. And for polyatomic gas like this. So the first curve, second curve, and third curve. This is for monatomic. This is second one is for diatomic, and the third one is for polyatomic gas. Now, what is the difference here? The difference is gamma. Okay, so gamma is different for different gases. Gamma is the ratio of the principal specific heat capacities. Cp by Cv is equal to gamma, and this only is called by the name adiabatic constant. This is called as adiabatic constant, and the value of the adiabatic constant for mono, diatomic and polyatomic gases will differ. So for example, you take the monatomic gas means the value of gamma is taken as 1.67. For diatomic gases like air, the value of gamma is found to be equal to 1.4. And for polyatomic gases, the value of gamma is found to be 1.33. Where gamma is the ratio of the principal specific heat capacities, which is called by the name what? Adiabatic constant. Okay, students. Now these curves are generally called by the name adiabat. Like the isothermal curve is called by the name isotherm. The adiabatic curve is shortly called as what? Adiabat. So how many adiabats I have drawn here? 3 adiabats. And you take any one graph, say for example the middle one. On this graph 2 points I will take and I will find the slope. If I find the slope of this graph, okay, the slope of this graph will be equal to dp by dv. So dp divided by dv, it can be shown that the slope is equal to minus of gamma times p by v. Minus gamma times p by v. So this equation can be derived by differentiating this equation. Okay, so p into v power gamma is equal to constant. This equation, when you differentiate, you will get dp by dv is equal to minus gamma times p divided by v. Whereas for isothermal what? Isothermal slope is minus p by v only we got. So the slope of this adiabatic curve is steeper than, greater than that of the isothermal curve. By how much times means? Gamma times. This is very important information for competitive examination going students. Okay children, now after this I am going to write the first law of thermodynamics. So the first law of thermodynamics. In the first law of thermodynamics, the quantity of heat supplied to a system is equal to the change in the internal energy of the system plus work done. Is it not? But in the adiabatic process, what is Q equal to? Q supplied to a system is equal to 0, is it not? So 0 is equal to du plus W, or du is equal to minus of W. So this is the equation of the first law of thermodynamics for an adiabatic change or adiabatic process. So if du is the increase in the internal energy of the system, when the internal energy of the system increases means okay, the work done will be what? Negative. So if du is positive means work done will be negative. If du is negative means then the work done will be positive, as vice versa. Understand? So now you take for example, what will happen when the piston is pushed downwards? When the piston is pushed downwards, work is done on the system. Is it not? When work is done on the system means it is negative. But due to compression, heat will be produced or not, and it increases the internal energy of the system. Suppose if suddenly if you pull the piston in the upward direction means what will happen? The internal energy, that is work is done by the system. So work done is positive and the internal energy will decrease. Okay. Now there are two conditions. Okay. What are the two conditions required? What are the two conditions required for an adiabatic process? Condition number 1 is the container should be fully insulated. Understand that? So thermally insulated container, I can write shortly thermally insulated conductor or vessel, thermally insulated vessel, and the process should be very fast. Process must be rapid. Understand? Rapid. That means fast. And you can also use the word sudden process. Whereas we have studied isothermal as what? A slow process, is it not? Whereas adiabatic process must be a sudden and rapid process. So my dear students, what is an adiabatic process means? It is a thermodynamic process in which all the coordinates, pressure, volume and temperature also will change. Okay, how? Under water condition. Under what condition? That is, under the condition that no heat will enter into the system or leave the system. That means under perfect thermal isolation or thermal insulation. I hope you must have understood well. Fine.